Okay, continuing with some coding. So now let's do the optional challenges. If you're up for some more challenges, try implementing the following features to your program. So far, the Magic 8 Ball provides 9 possible fortunes. Try to add a few more possible answers to the program. To do this, you will need to increase the range of randomly generated numbers and add additional else-if statements for each new answer. So what I could do is change it from 9 to 11, and it's inclusive, remember, and now I can say elif random number is equal to 10 colon answer will be have assigned to it the value I'm hungry. Elif random number has assigned to it 11 colon answer will have assigned to it that's not the question you need to ask. Cool. What if the asker does not provide a name such that the value of name is an empty string? If the name string is empty, the output of the program looks like the following. Space, white space asks, will I win the lottery? As you can see, the formatting of the output can use some improvement when there is no name provided. We can address this by printing out just the question such that it looks like the following. You can implement this by creating an if-else statement such that, if the name is an empty string, it will only print the question. Else, the player's name and question are both printed. So we can say if name is not equal to emptiness, then print name asks question, else meaning no if the name is not equal to else print so if the name is not equal to nothing, meaning if there is a name, then print name asks question Magic 8 Ball's answer and the answer, else print Magic 8 Ball's answer and then the answer. So we've got syntax error. We missed the colon. Brilliant. So if I provide nothing for the name and run it, I still want to print the answer. Print question. Yeah, print question. Cool. Task 14. What if the question string is empty? If the user does not provide any question, then the magic 8 ball cannot provide a fortune. Otherwise, the fabric of reality is at risk. To ensure that the fabric of reality is safe, we can create an if-else statement, where if the question is an empty string, print out a message to the user, else print the name and question with the magic 8 ball's answer. So we can say, if question so I think we can put all of this into an if statement. So if question is not equal to nothing, so if we make the question be nothing and do save, it says you need to provide a question, dude. And in fact, we could change dude to the name. You need to provide a question, Jeff. Okay, let's get an AI code review. Let's review your project work. This AI-generated code review offers specific feedback about your code. You can also ask yourself these same questions when reviewing your code on your own. Purpose. Does the code do what it's supposed to do? Well, your code successfully generates a random answer for the magic 8 ball based on a random number, fulfilling the main purpose of the project. The random number range should be between 1 and 9 as per the project requirements. Adjust the range to match the specified answers. Well, it's not quite true. Ensure that the sources match the specified list in the project. My sources say so should be my sources say no. Okay. Readability. Is the code easy to understand? Your code is well structured with clear variable names, making it easy to understand. Consider adding comments to explain the purpose of each section, especially the control flow logic. Okay, performance. Does the code run efficiently? The code efficiently uses control flow to determine the magic 8 ball's answer. Consider using a dictionary to map random numbers to answers for a more scalable solution. So instead of saying if random number is 1, the answer is yes, definitely. If random number is 2, answer is it is decidedly so. You could say answers, and then we assign to it this thing in curly brackets or braces. So 1: yes, definitely. 2: it is decidedly so. And then we say answer equals answers. We'll assign to answer answers.get random number error. I mean, that's very cool, isn't it? That's very cool. So we could... I don't want to change the code though, because then it will untick the thing and then I won't be able to click next. But yeah, so you could use a dictionary. So what's happening is we've given our dictionary a name, and then we can do answers.get. So we can do the name of the dictionary .get. So if we called it puppy, we could do puppy.get, but we happen to have called it answers. And we do answers.get, and then we feed into arguments random number and error. And random number is the name of the thing we got from the rand integer function. Cool. Project complete. You earn 25 XP each towards your skills. Sal runs the biggest shipping company in the Tri-Country area, Sal's Shippers. Sal wants to make sure that every single one of his customers has the best and the most affordable experience shipping their packages. In this project, you'll build a program that will take the weight of a package and determine the cheapest way to ship that package using Sal's Shippers. Sal's Shippers has several different options for a customer to ship their package. Ground shipping, which is a small flat charge plus a rate based on the weight of your package. So a small flat charge, meaning it's the same for everyone, however much it weighs, but then there is another charge that varies. So that's ground shipping. Then we have ground shipping premium, which is a much higher flat charge, but you aren't charged for weight. And then drone shipping, which is new. There's no flat charge, but the rate based on weight is triple the rate of ground shipping. Here are the prices. So for ground shipping, it could be, your package could be £2 or less. It could be over £2, but less than or equal to £6. It could be over £2, but less than or equal to £10. Or it could be over £10. And the price per pound... Oh, the flat charge for each of these weight categories is given here, so it's $20, $20, $20, $20, $20, and the price per pound, meaning pound as in weight, is $1.50, $3, $4, $4.75. Then we have ground shipping premium. Again, there's a price per pound, £2 or less, over £2, but less than or equal to £6. Write a shipping.py Python program that asks the user for the weight of their package and then tells them which method of shipping is cheapest and how much it will cost to ship their package using Sal's Shippers. So what you're feeling now is the need to think. So we need to ask let's just start with anything, right? We need the user to say the weight of their package. So we need that input function. So input, we might say what is the weight of your package, or provide the weight of your package. So provide the weight of your package. Is that okay? So it looks like you have encountered an EOF error. An EOF error, which occurs when the input function is expecting some input but reaches the end of the file. So EOF end of file instead. This can happen if you're running your script in an environment where it cannot prompt for user input, such as certain online interpreters. To fix this issue, you can replace the input function with a predefined value to bypass the need for user input. Here's an example of how to fix this specific line. So we might just say weight equals 5. Alright. Weight in pounds, or I'm going to call it weight in pounds, equals 5. So we need to tell them which method of shipping is cheapest. So first we need to work out how much it'll cost for each method of shipping. We just have to, otherwise we can't compare them. So with ground shipping, I think it wants me to do it with control flow. So we can use match. We can do a match block. Weight in pounds. So we have the case in which, and I think we have a colon. Let's try and remember how we tie it all together. The case in which weight in pounds weight in pounds is less than 2. So in the case that weight in pounds is less than 2, we can print your, no. If the weight in pounds is less than 2, then we'll call it the ground shipping price. The ground shipping price will be, we'll have assigned to it a value of, well, we don't know. Well, it will be weight in pounds multiplied by 1.50 plus 20 pounds. Okay. So if we say, if the weight in pounds is 5, then we have a case where the weight in pounds is less than 2, then we do weight in pounds multiplied by 1.50. There might be a case in which weight in pounds is greater than 2 and weight in pounds less than or equal to 6, and in that case the ground shipping price, I'm just going to copy this line, the ground shipping price will be the weight in pounds multiplied by not £1.50 but £3 plus the flat charge of 20. But there may be a case in which the weight in pounds is over £6 and less than or equal to, and weight in pounds is less than or equal to 10, in which case the ground shipping price will be the weight in pounds multiplied by 4. There may be a case in which the weight in pounds is greater than 10, and that in that case will be the weight in pounds multiplied by 475 plus 20. Wow. Great. Do you know what? Let's just use ChatGPT. So I want to check, first of all, that I am using the correct sort of syntax for that. So I was wondering if you might help to correct some code I've written. I'm writing Python, and I'm writing a program that will take the weight of a package from the user and tell me the best price for that user. There are 3 price classes. So we have ground shipping premium, ground shipping premium, and drone shipping. Ground shipping premium, and drone shipping. And for each of these classes there is a table listing the flat price and a price per pound for various classes of weight. Here is my code so far. Well, your code has a few issues that need addressing for proper functionality and syntax compliance. I'll guide you step by step and correct it. Now, the input function's result is not being stored. I've just put input provide the weight of your package. And also weight in pounds is being hard-coded to 5. The match statement is not being used correctly. Match case is for pattern matching, but you're trying to implement a logic-based conditional structure. Syntax errors are present. There are missing colons in case statements. And 4, the logic is better suited for if, elif, else, since you are comparing numeric ranges. So we might change it to using if statements. If weight in pounds is less than or equal to 2, the ground shipping price will be the weight in pounds. If the weight in pounds is less than or equal to 6, then this will hold. If the weight in pounds is less than or equal to 10, then this will hold. And then finally we have the else. So I'm going to copy that. And something else they've done is they've put float on the outside of the input function. So back to here and place it with that. And now it works. Well, it still doesn't work, but anyway. Next, what we need to do is calculate the ground shipping premium price, and I'm just going to copy this code because it's going to be very similar. And make that a comment. Calculate the ground shipping premium price. Now, if the weight in pounds is £2 or less, ground shipping premium price equals weight in pounds multiplied by £4.50 plus nothing. So I'm just going to remove that. And then it's if the weight is pounds is else if it's less than or equal to £6, that's correct, then the ground shipping premium price will be equal to the weight in pounds multiplied by 9. And again, there's no flat rate, so I'm going to remove that plus 20. And if the weight in pounds is less than or equal to 10, the ground shipping prem price will be weight in pounds multiplied by £14.25. Yeah, £14.25, and there's no flat rate. Else, no, 12 pounds. Else, the ground shipping premium price is equal to the weight in pounds multiplied by £14.25. And then we would calculate the drone shipping price. Oh, no, that's what we've just done. Okay, fine. Rename that as the drone shipping price, but first we need to calculate the ground shipping premium. Oh, okay. So ground shipping premium is slightly different. There's just a flat price. So we'll assign to ground shipping prem price the value of just £125, I think. Yeah, 125. There's no sort of banding. There's no price per pound for that. And change this to drone shipping price. Drone shipping price. Now we know the ground shipping prem price and the ground price and the drone price. So what we can do is the sort function of the ground shipping price and the ground shipping prem price and the drone shipping price, and is that right? And we want to get the lowest one out of that list. So I don't know how to do that. So what I want to do is inform the user which shipping option will be most cheap for them. I need a way to sort amongst the free shipping options and select the lowest one. I've already had a bit of a go using the sort function, but I'm not quite sure how to use it. So you're on the right track. To determine the cheapest shipping option, you can use Python's min function instead of sort, as you are only looking for the smallest value among the options, not sorting them all. Here's the corrected and expanded version of your code. What they've done is created a dictionary with the name shipping options. So they've said shipping options and assigned to it something in curly brackets or braces. Hold on. So where were we? Right. So yeah, we don't want to use sort like that. ChatGPT says what we do is have a shipping options dictionary, ground shipping, ground shipping price, ground shipping premium has a value of ground shipping premium price. So all the values are the values we've established using this control flow. Then we're going to find the cheapest option. Cheapest option will assign to that min of shipping options, comma, key equals shipping options dot get. Cheapest price. Now we have a new variable called cheapest price. So we have cheapest option and cheapest price. Cheapest price equals shipping options. Again, the name of our dictionary, shipping options, and then we have square brackets, and we put in the square brackets cheapest option. So we feed in the variable here. I just really want to take a few moments to understand this because I think this is quite difficult. Okay, this block here is just displaying the results. So print f string \n shipping options. This is an f string for option price in shipping options.items. Print f option $$ price.2f. So the shipping options dictionary, it stores the shipping options as keys and their respective prices as values for easy comparison. We have the min function. It finds the option with the minimum price using key equals shipping options, so key equals shipping options.get, which retrieves the price for comparison. The formatted output. The program prints all options and highlights the cheapest one. When you run this program, the user will see all available shipping options and which one is the most economical. So I'm going to copy that now. And put that in. But there is something I want explained. What is this line all about? So we have cheapest price equals shipping options and then cheapest option. Perhaps you can explain what this line is doing. Certainly, let's break it down. So it says cheapest price, and we assign to cheapest price shipping options cheapest option. So cheapest option, this is holding the key of the cheapest option. We've kind of set it up. It's determined earlier by the min function, cheapest option is. So we have cheapest option and we assign to it using whatever the minimum function extracts. Here min returns the key, e.g. ground shipping associated with the smallest value in the dictionary. Shipping options cheapest option. Well, this line with the square brackets, shipping options square brackets cheapest option, this retrieves the value from the shipping options dictionary corresponding to the key stored in cheapest option. Again, this retrieves the value from the shipping options dictionary corresponding to the key stored in cheapest option. Again, this retrieves the value from the shipping options dictionary that happens to correspond to match the key which is stored in cheapest option. Stored in cheapest option. For example, if cheapest option equals ground shipping, this line would retrieve shipping options ground shipping, which might be something like 25. And then we assign it to cheapest price, the variable called cheapest price. The value retrieved from the dictionary is assigned to cheapest price for further use in the program, such as displaying it to the user. So suppose, and we have an example walkthrough here, so suppose we say shipping options is the name of our dictionary. Here's the dictionary in curly brackets. And we have the first key value pair, so we say ground shipping, colon 30. Ground shipping premium, colon 125, and drone shipping, 40. The program finds the key with the smallest value. So we assign to cheapest option, ground shipping. The program then retrieves the price for that option. Shipping options, square brackets, we say ground shipping, and then we assign 30.0 to it. Retrieves the price. Just focus it. So that's the dictionary name on the outside of the square brackets, and then ground shipping. Okay, But of course we don't put ground shipping, do we? I know that's the name of the key in the dictionary, but we don't. If you look at the code, what they do is they say shipping options and then just cheapest option. They don't put like ground shipping there. You know, that is not the name of a key in the dictionary, is it? We've got a key called ground shipping, a key called ground shipping premium, and a key called drone shipping. But there's not cheapest option per se here, is there? So that's how they do it in the code. They just put cheapest option in the speech marks. So this example walkthrough is a bit misleading because they put the name of a key in the square brackets. But anyway, we assign 30 to cheapest price. So cheapest option equals, we'll assign to that ground shipping, cheapest price, we assign to that 30. This allows you to print both the option and its price for the user. You know, I think if we're going to copy code from ChatGPT, we should at least be able to write it out ourselves. So forgive me here, but so we'll do comment find the cheapest option. Yep. Again, comment find the cheapest option. Again, comment find the cheapest option. Option, the CO, the cheapest option. Find the cheapest option. And then the first line is going to be cheapest option equals min function. So cheapest option, a variable, equals min, and then we'll have brackets. And then we put in two arguments. So shipping options, comma, and then key equals. Okay, so again, shipping options, comma, key equals shipping options dot get. Okay, so it's key equals shipping options dot get. Key equals shipping options dot get. Correct. Again, key equals shipping options dot get. Correct. Again, key equals shipping options dot get. Again, key equals shipping options dot get. So cheapest option equals, so we have a variable and we pack it all into that variable. So we say cheapest option equals the min function, shipping options, comma, and then again shipping options, but dot get. Oh no. So min shipping options, comma, key equals shipping options dot get. Again, cheapest option equals min shipping options. Now we bring into that minimum function shipping options, comma, key equals. You can't just do shipping options dot get. So you can't just do shipping options dot get. You have to say key equals shipping options dot get. Okay, so it's shipping options, and already be thinking it's got to be key equals shipping options, comma, key equals shipping options dot get. Good. Then what? So we've assigned that packed that into cheapest option. Now we need a new variable, and we're going to call it cheapest price. Okay, and we assign something to that. So again, cheapest option, then cheapest price. So we'll have cheapest option, and we'll use the min function, and we need to bring in the shipping options. So cheapest option, min function, bring in the shipping options, and key is equal to, because the minimum function is working on a dictionary. And what's a dictionary made of? Keys. So you can see now it has to be key. You have to specify key. It has to be key equals. But then we can just put shipping options dot get. Next line. Cheapest price. Yeah, good. So then we have, cheapest option, cheapest price is going to be equal to shipping options, name the dictionary again. Name the dictionary again. Shipping options, what do we need to do now? So we've already done get on it. Yeah, but that was part of the minimum function. That's the minimum function. So that was doing work on finding out which the minimum function is. So shipping options and then get. Well, we're not going to name one of the keys, because if we named one of the keys, that would be ignorant. That would be just. We want to tie it into the knowledge of what's the smallest one, the minimum one. So we now put in cheapest option. So it's shipping options and cheapest option. Shipping options, and then put in a variable name inside these square brackets. And our variable is cheapest option. Correct. So this is how we find the cheapest option with these two lines. We use the minimum function, assign it into cheapest option, and then you can feed cheapest option into our dictionary sort of picker. This is our dictionary picker. We want to display the results. So I'll say hashtag display the results. Print, and then opening rounded bracket, and then F. Let's have a look at that. Why are we putting F inside the rounded brackets of print? Can you explain why there is a lowercase letter f inside the rounded brackets on this line? Certainly. The lowercase f in this line, so f and then \n and then shipping options : it indicates that this is an f string, so f for f string, and it's short for a formatted string literal. So f string, formatted string literal, for f for formatted string literal. Introduced in Python 3.6, f strings are a way to embed expressions directly inside string literals. The f before the string tells Python to evaluate any expressions within curly braces and include their results in the string. Again, the f before the string tells Python to evaluate any expressions within curly braces. Yeah, but there aren't any curly braces. And in fact, I think they know that, because they say, why use the f here? Using an f string here may be unintentional or added out of habit, because other lines in the program likely include f strings. Like, there is a line where we say f before the opening speech mark, and in the speech marks we say option : $price dot to f. You see that? Option and then $price, and we have dot to f, as if there's two f's. Now that we do need an f for, and maybe because there's an f there, we've done an f on this line. So the key details in this case, let's stay with it. So the f prefix, it indicates that the string supports expressions which are going to be evaluated. Again, think of the word evaluate meaning like collapse down. No expressions. Now in this specific line, there are no curly braces, which is what I said, containing expressions. So the f is not strictly necessary here, because the string does not include any variables or any expressions to evaluate. This line would work the same without the f. So we could just have print and then \n shipping options : So yeah, let's remove that. Why is there a \n? \n. It's the new line character. Here's why it might be there. It tells the program to start a new line. In the context of your program, the new line is likely used to create space between sections of your output, making the display more readable. And notice how it goes within the speech marks. It goes in the speech marks, not on the outside. So it would output blank line and then shipping options. Without \n, the output would look like this, just shipping options. So there'd be no blank line. So here's an example without \n. Print first line, print second line, we just get first line, second line. But with \n, we get print first line \n, print second line. Well, because we've got that after the actual text of the first line, we get first line and then a blank line and then the second line printed. So we want it to say shipping options, but on a new line. And next time we're going to explain what's going on with this here. For option, price in shipping options, which is the name of our dictionary. So we created a dictionary called shipping options. And now we're saying for option, price in shipping options. Or rather, for option price in shipping options dot items, print f option price dot to f. So you have a loop that iterates through the shipping options directory, the shipping options dictionary, where option represents shipping method names and price holds their costs. For each option, it prints the method and its price formatted to 2 decimal places.